After placing the CPU on the rack, we need to go after the input and output modules. The input and output modules are grouped in the subgroup of the SM300 folder in here. As you can see here, all kinds of digital and analog input and output modules can be seen. In this lesson, we want to learn how to select the desired digital input card from here and place it on the rack. The digital input cards are grouped in the subgroup of DI300 folder. In here, each and every one of the modules is represented with a special code, just like what we had for the CPUs. They show the general information about the modules. For instance, for this DI module with code SM321 DI16 DC 24 volts, DI16 shows us that this module is a digital input module with 16 inputs, meaning that it can receive 16 input signals from 16 different facilities. 24-volt DC also tells us that this module requires a 24-volt DC in order to turn on, which, as we have said already, the power supply provides us with this voltage and turns our module on. We can also see the order number of the digital input cards, like other modules, in this box found below. If we need any more information than this info about our desired module, we can right-click on it and choose Product Support Information, so this page from Siemens' website opens up for us. We can get access to other complementary information about this module in here. It's important to know, though, that not all modules we have work with the 24-volt DC. Some of the other modules we have here work with AC voltage. For example, the module that has AC 120 volt at the end works with 120 volts AC, meaning that in order to turn this module on, we need to apply a 120 volts AC to it. Other modules, like this one, work with both a 120 volts AC and with 230 volts AC. Therefore, depending on the need in our project, we can choose our desired card with a suitable input voltage. However, as we mentioned earlier, the 24-volt type of these cards are more common. Now, what about the modules like this one here that have interrupt as a suffix in their code? These modules are the modules that give us a specific ability compared to the usual DI modules. For instance, we can set them in such a way that if the input wire that connects the sensor to the module gets disconnected, the PLC runs a specific program for us. For example, it activates a certain output, and depending on the activation of that output, a message appears on the HMI page and notifies us about the sensor wire disconnection. We're going to talk about how to configure these cards with interrupt abilities in the future courses in more details. So, we have a series of other modules that have the word namer in their suffix. The DI modules that have this suffix in their code have the ability to receive the namer sensor signals. Now, what is this namer sensor? These sensors are the ones that when they connect to the PLC can recognize whether they are on, off, or their wire is disconnected. Now, how is this recognizable by the PLC? How can the PLC realize that the namer sensor, which is connected to the DI card, is on, off, or if its wire is disconnected? Take a look at this picture. This figure shows how to connect a namer sensor to a DI module. In here, if the sensor is on, the resistance of the two ends of the sensor is 1 kilo ohms. Why? Because in this situation, the 10 kilo ohm resistance we have here is short circuit. If the sensor is off, the resistance between the two ends of the sensor becomes 11K ohms, and if the sensor is disconnected, the resistance is infinity. The DI modules that have namer suffix in their codes in fact have this ability to measure the resistance of the ends of the sensor and recognize if the sensor is on, off, or disconnected. So the word namer in the DI module code is the ability to connect to the namer sensor. There are other series of DI modules in here with X as a suffix. These modules are the explosion-proof modules, meaning that they are applicable in cases where there would be a possibility of explosion, and we need to use explosion-proof modules. So, the code of the DI module we have here is DI32 DC 24 volts. This means that our module has 32 inputs and its input voltage is 24 volts DC, meaning that in order to turn this module on, we need to connect it to a 24 volt DC. As you can see, we have two 32-channel DI cards with 24 volts in here. Now, which one should we choose and place on the rack? Here, we need to read the order number of the DI module that we have in the enclosure, and then we need to select the exact same card with the exact same order number in hardware configuration. The order number of our card is 6ES7-321-1BL00-0AA0. Therefore, as you can see, the order number of this module matches with the order number that we need. So, just like before, we select our desired slot on the rack and then place it on the rack by double-clicking on our desired module. Now, a question here is, why did we place our module on the fourth slot rather than the third slot? The reason for that is we can only place an IM module in the third slot in hardware configuration, and if we want to place any other modules rather than the IM in here, as you can see, it tells us that the module can't be placed on this slot. What should we do, though, if we don't have an IM module among the entire modules that we want to use in our project? In this case, we need to leave the third slot empty and don't place any modules in there. Now that we have left the third slot empty in here, are we supposed to leave the slot empty in the enclosure? Are we supposed to leave a space and install the next module a bit further away? The answer is negative. Why? Because if we leave an empty space in the enclosure on our rack, the CPU loses contact with the rest of the modules and it can't transfer data with them anymore. Hence, whenever we don't have an interface module, we leave the third slot in hardware configuration empty, but in the enclosure on the main rack, we place the modules close to one another with no space between them. This was the DI module configuration. In the next lesson, we go on about the configuration of digital output module.